Good morning. Let me raise my head up a little bit. We're looking at creationism versus evolution and the effects of a worldwide flood, actually the evidence of a worldwide flood. And we're looking at evaporite beds. That's in K31. Looking up evaporite beds. Here it is. Relative to evaporite beds, another type of sedimentary deposit that may seem difficult to compress into a short span of time is found in the great beds of the so-called evaporites. These consist mainly of salt, gypsum, and hydrite, which is calcium sulfate, beds. The term evaporite is applied to these deposits because it is believed that they were formed by long continued evaporation from inland seas or lakes containing saline water. So the evolutionists say it took a long time. How otherwise? A supposed modern example is the Dead Sea, where the evaporation rate is very high, about 120 inches annually. And where the water continually entering the lake has no other outlet than evaporation. The Dead Sea, of course, is known to have an extremely high concentration of chemicals of various kinds as a result. And it is believed that this process, if continued over long ages, would produce beds of evaporites, such as are found in many places in the geologic column. But at present rates, this process would obviously require hundreds of thousands of years to produce such beds as are actually found in the data. A point for evolution? Well, there's always the possibility, we can't rule out the worldwide flood yet, that the evaporite bed was formed by transportation from some previous location where it may have existed since the creation. And there's also the possibility that it may have been formed by intense application of heat for evaporation of large quantities of water in a short time, rather than ordinary solar heat acting over a long time. Just because you show evidence in one direction doesn't mean you rule out the direct evidence for the other direction. One of the most important types of evaporite deposits in the salt dome is the salt dome. These structures are often associated with petroleum and so often have important economic implications. Their tremendous size is indicated by the following. The salt core generally stands vertical or nearly vertical and has a roughly circular or oval horizontal section measuring from 1,000 to 2 miles, 1,000 feet to 2 miles or so in diameter. It extends downward 15,000 and even 20,000 feet, so that's pretty large. Leahy says, it would seem the height of absurdity to imagine that these huge thicknesses of salt had been built up by evaporation of standing water. It would require complete evaporation of a body of sea about 8,000 feet deep to produce a depth of only 100 foot of salt. Nevertheless, evaporation or other precipitation from solution was considered for a long time, and it was to be considered to be the proper explanation for such beds. However, a much more realistic interpretation is now generally accepted. Although many theories have been proposed to explain the origin of these salt domes, the view most commonly supported in America is, until the early 1920s, was that the salt was deposited from ascending waters. However, serious objections to this theory have been presented. In Europe, where the domes are often laid bare to considerable depths by erosion, and where consequently a more certain idea of their structure and origin is obtainable, geologists came to believe that the salt was thrust upward into the sediments like a punch, but principally by mechanical means, assisted by the ordinary processes of granulation and recrystallization supposed to accompany the development of schistosity in metamorphic rocks. In terms of biblical geology, it would seem reasonable to attribute these original salt beds to the activities of the creation period, with the intrusions forming the salt domes being associated with the other volcanic and tectonic activity during the deluge period, cataclysmic type of activity. And if tectonic activity can suffice to explain these most spectacular of the various types of evaporites, there seems to be no reason why it cannot also explain, at least in part, many of the others. As a matter of fact, the principle of uniformity has been quite unsuccessful in accounting for the more extensive evaporites of all kinds, as well as for the salt domes. For example, the relict sea, by which is meant a basin formerly freely connected with the ocean, but which is now nearly isolated and therefore gradually drying up. But none has produced evaporites at all comparable in scope to those in the older strata. Tremendous depths of water are indicated to account for the deposits, or else there must be some continuing subsidence together with a continued influx of marine waters into the relict sea. There is no place in the world today where this combination of features is found. Hence, there must again be added to the uniformitarian principle a sizable increment of pure imagination to account for the great salt and gypsum beds. Science, pure imagination. In view of the difficulties encountered by uniformitarianism in attempting to explain the great evaporite beds, and the need to postulate either some kind of brine which does not now exist, or some special conditions of evaporation and metamorphism that are not known to exist at present, perhaps it is not too presumptuous to suggest that these unusual brines may have been generated during the volcanic upheavals accompanying the deluge, and that unusual conditions of vaporization and separation of precipitates may likewise have been caused by the locally high temperatures accompanying these same upheavals. The catastrophic environmental factors associated with the flood provide a more satisfactory framework within which to develop a satisfactory hypothesis than does the alternate procedure of pure speculation. Now we have cave deposits, stalactites and stalagmites. A different form of evaporite, which is popularly believed to require long periods of time for formation, is the familiar stalactite and stalagmite found in limestone caverns. These are formed by the evaporation of lime-bearing waters percolating through the cavern root. Obviously, the rate of such cave travertine formation depends mainly on the rate of percolation of the source water. The fact that this rate may be very slow at present certainly does not mean it has always been so. Thornberry says, various attempts have been made to estimate the rate of formation of cave travertine, which is a layered calcium carbonate deposit. But so many variable factors affect the rate of deposition that it is doubtful if cavern ages arrived at this method very accurately. The caverns themselves are believed by most cave geologists to have been formed by solution of the limestone rock at a time when the rocks were saturated. When the gradual lowering of the water table, it is obvious that the percolating waters would for some time still be quite plentiful, only gradually lessening in amount. Thus, the rate of formation of stalactites and stalagmites would be rapid at first, gradually leveling off to present rates. Even under modern conditions, it is quite possible for the formations to develop rapidly. The speleologist, the cave exploration specialist, Hendricks says, for example, how long does it take for a stalactite to grow? There is more than a little evidence that growth is considerably rapid. First of all, stalactites are found in man-made tunnels that are only a few years old. Second, certain conditions are so favorable to dripstone growth that as much as several cubic inches a year may be deposited in a single stalactite. Third, there are many examples of large stalagmites growing on blocks of stone that have fallen away from cave dwellings and ceilings. Consequently, Hendricks says, to attribute great lengths of time to the formation of such cave deposits is not only unnecessary, but unreasonable as well. Dr. Don Patton, one indication of great age is often argued for the formations that we see in caves. We are told that the speleotherms, the stalactites and stalagmites, take thousands of years. This statement is one of the geology textbooks from which I was taught, says it takes 100,000 years to form 1 cubic inch. Now that's an absurd statement, and most geologists know better than that, but that's what is in some of the textbooks. We have seen these stalactites drapery formations and stalagmites form very, very rapidly. I was told by an individual who was a researcher with the National Speleological Society that in Indiana, near Blue Springs, at the George Rogers Clark Memorial, in the basement there were formations just like you find in caves. In the basement, man-made. Now this stone that forms this memorial was quarried just 6 miles from Blue Springs Cave. And the water percolating down through the rocks and the cracks of these limestone blocks has produced formations just like you find produced when the water percolates down through the cracks in the caves. They're in the memorial building. We found that exactly what we find in the caves. If we'll notice these drapery form formations hanging from the fixtures in the basement, we also see the stalactites and the stalagmites that were formed in the building that was at that time less than 40 years old. In fact, there were large columns of limestone deposition that we found 11 feet tall, 40-year-old building. And there were 5 of them, like this, 11 feet tall. Now, if this can form in less than 40 years, I look around considering that someday that the Earth is supposed to be billions of years old. Where are the huge ones? I mean, the really huge ones. No, it does not take a long time to do this. Maybe the Earth is young. It's dependent upon the concentration of minerals, the rate of flow, and the ventilation. A number of factors control it. But when the factors are right, they form very, very rapidly. We have Dr. Patton's notes here. Changes in atmospheric partial pressure of carbon dioxide produce corresponding changes in carbon dioxide solubility. Because of these relations, there is a direct connection between atmospheric carbon dioxide and that amount of dissolved calcium ion in seawater. If the carbon dioxide dissolved in seawater decreases, some bicarbonate ions change to carbonate, thereby causing precipitation of calcium carbonate, precipitating the advanced formation of stalactites and stalagmites. And Mr. William C. Sloss, Department of Geology, Northwest University. Hanging from ceiling beams in the 40-year-old building's basement are several rows of formations not usually seen so close to the ground. Stalactites. Yep, stalactites. More than 100 of the squiggly, slippery rock formations that thousands of people pay to see in places named Carlsbad and Mammoth. They are natural cave ornaments, pure and simple. Deputy Chief Ray Hawkins has been parking in the basement of the building at Harwood and Main Street since the 1960s and can't remember a time when the mineral sickles weren't hanging around. We have buried forests also support worldwide flood, cataclysmic event. Another important type of sedimentary phenomenon that seems at first to require much larger periods of time than the Bible would allow is found in cyclically repeated deposits, each cycle of which seems to require a certain more or less measurable time in which to be formed. An oft-quoted example is the so-called succession of buried forests on Amethyst Mountain in the northwestern part of Yellowstone National Park. J.L. Krupp discusses these as follows. In Yellowstone Park, there is a stratigraphic section of 2,000 feet exposed which shows 18 successive petrified forests. Each forest grew to maturity before it was wiped out with a lava flow. The lava had to be weathered into soil before the next forest could even start. Further, this is the only a small section of stratigraphic column in this area, and it would be most difficult for flood geology to account for these facts. Flood Geology, Journal of the American Scientific Affiliation. Many of these trees, petrified trees, are prostrated and in various positions. Those that are upright apparently remain in that position due to the weight of their root system and attached soil as they were rafted into their final burial place. The so-called petrified forests are in reality only stumps. There are no limbs or fossil foliage, as one would expect if the complete trees had suddenly been inundated by a shower of volcanic fragments and ash. Neither are the root systems complete. Only occasional trees remain upright and show some parts of the root system still attached. The stumps give every appearance of having been in some manner sheared off by some overwhelming force, possible tsunami-driven debris, then uprooted and transported and sorted out from other materials, and then suddenly buried beneath a volcanic shower. Then came another wave of sediment and stumps. Several layers of sediment, however, appear to be without any stumps. possibly resulting from a tsunami generated by the preceding eruption, then another volcanic shower, and so on. The whole formation, as does the volcanic terrain of all over the Yellowstone region and the Pacific Northwest, literally